reactor vessel and refueling operations.
Oh my goodness. So that's a nuclear...
I never get tired of that. Welcome back to my reaction to Smarter Every Day visiting Browns Ferry nuclear plant during a refueling outage. This is part 2. If you haven't seen part 1, I will pin it in a comment down below.
Hey, what's up? We're on the refuel floor now?
We're on the refuel floor.
Okay.
We can go ahead and take you up to the crow's nest. It's probably the best place to be.
What all are you carrying in?
Are you going into foreign material?
Yes, that's what I was trying to figure out.
Yes. Foreign material exclusion with all the camera stuff.
How to
go about it.
Would you like this on my head?
I met Jeffrey from FME, or Foreign Materials Exclusion.
Yes.
I didn't really understand what he was doing at the time, but he was starting a process that was happening in the background. He looked at all the cameras that I wanted to take out over the reactor, and he started working a solution for how to attach them to me.
Why don't we come up here?
Yeah, you really don't want to drop those cameras into the refueling cavity. There was one incident during a refueling outage where the residual heat removal pump, so the pump that keeps the reactor decay heat removed, sucked in a face shield that was inadvertently dropped into the refueling cavity, and then the pump proceeded to tear itself apart. Didn't result in any radiological accident or damage to the core or anything like that, but it did extend the refueling outage by quite a bit because they had to get that pump fixed. These foreign material exclusion or FME events can get quite expensive.
We're in a really interesting place, but everybody's all business.
Yep, nuclear professionals.
All right, so this is our refuel floor. You got 3 units up here. You can see all 3 units spent fuel pools. You can see all their bridges and everything like that. We're currently in refueling operations on unit 2 right now. They're right over the fuel pool and they're moving either blade guides or fuel over to the reactor at this point in time. They're actually in the process of shuffling their fuel.
Okay, so I didn't realize when I heard nuclear fuel unit 1, 2, 3, or nuclear reactor units 1, 2, 3, I didn't realize it was all under one roof.
Oh yeah.
I didn't know.
That isn't necessarily a common thing. Or let me rephrase that. That isn't a universal thing. Units 1 and 2 were very different at the plant that I worked at, and they were physically separated in completely different buildings.
Yeah. Yeah, so, it's a big building.
So that's a reactor.
That's right.
That's a fuel pool.
That's right.
That's a fuel pool.
That's right.
That's a reactor. And then what do I have going the other way? Oh, square
fuel
first.
Pool and a reactor.
Fuel pool
Unit 2 and 3
Just
look
like
identical
that.
to each other.
Why are these fuel pools next to each other?
So they were made.
So that's why they call it secondary containment here, because the actual ones are around each individual reactor vessel, which of course in the outage unit is completely disassembled so they can refuel.
Originally when it was constructed, they just constructed unit 1 and 2 as mirror objects of each other, and then at some point in time during initial construction they said we want to add a 3rd unit to it, and then just mirrored unit 2 again. So it's just from an original design.
I see. Interesting. And this was made when?
Back in the mid-60s.
Mid-60s. That's amazing. I can see into the pool. I can see the...
A lot of these plants are pretty old. Their initial license lasts 40 years, but you can get 20-year extensions. And it's not unheard of to even get a second or potentially a 3rd 20-year extension.
Tops of, I need to flip my camera to a tighter camera, I think. Let me do that. So there's a nuclear reactor around that ring. It's in the center of that. That's
right.
unit 1?
That's unit 1, correct.
Here's the fuel pool for unit 2. Now is this spent fuel or?
Yeah, the square is the spent fuel, that's correct.
Okay.
The spent fuel pools and the refueling pool being in the same structure. That's also not a universal thing. At the plant I worked at, they were separate buildings, and it even went through what's called the fuel transfer tube. Basically stuck it under. There was an upender which slid it and bent the fuel assembly back, slid it through the tube, and then took it back up, and then it was placed in the spent fuel pool harness. It kind of looked like a little strainer or grater or something.
And then The reactor's right there. Right now, are we taking fuel out of the reactor or are we putting it in?
So it's a little bit combination of both. We actually
Interesting.
we have 764 bundles in the core, right? And we only get about 350 new bundles every refueling average every couple years. So we actually reuse the fuel for about 6 years. So they call it a shuffle. You may be moving a once burnt fuel is what we call it, one cycle, and moving it to a different location in the core.
Okay, yeah, that's normal. Yeah, at the plant I worked at, only about a third of them were freshly new, and that you would have some once burn as well as some twice burn before you'd put them in the spent fuel pool.
Right now, the main priority for Fuel Shuffle 1 is to move the fuel in an appropriate location so that we can access the parts of the core that we want to do maintenance on.
That makes sense. Can you walk me through? I see a lot of people in this room. I see a lot of people doing different things.
Mm-hmm.
This looks like there's a lot of equipment over here that's not being used at the moment.
Yep.
Is this a monitoring station?
Yep.
Okay, so it's monitoring radiation. So I don't see any people here. I see these people here. They look like they're getting ready to...
You generally don't want people near the operating unit during an outage.
Yeah, so you got a bunch of groups that are working here. You've got some, I'll say, work management individuals down here.
That's
from
what these people
groups.
are doing?
These guys are tracking, helping track the fuel moves that they're on, making sure that they're on the right bundles, etc. They're also tracking the work that's going on the refuel floor, reporting to our outage control center.
Ah, that's why people are coming in and signing in with her.
That's right. They're just tracking the work of what's going on. That's really what they're doing.
Okay.
You got a bunch of boiler makers out there that their job is to essentially remove.
That's a little interesting. You have your work management people actually inside the reactor containment building. I think that's got to be the function of having it be 3 under 1 roof sort of thing, because I've seen it essentially at a smaller building outside where people sign in and get work started.
Disassemble the vessel.
Is that who you're seeing here?
There's a couple boiler makers down there. There's a bunch of miscellaneous stuff. If anything that requires any crane movement or anything like that outside of the bridge, you got boiler makers involved. You got form material.
And after all, the reactor vessel is just a really big boiler.
Individuals out there that are tracking what form material is going where.
Mm-hmm.
Okay, and then up on the bridge, they're over the reactor now. I'm seeing some people right at the edge of the reactor.
Yeah, those guys are actually part of our in-vessel inspection team. And what they do is they go and they have cameras that they put in the core, look at our nozzles, look at our welds, look at our all that stuff to make sure that there's no wear essentially, and that the life of the core is maintained.
Got it. And that's an individual on the bridge right there. Is that the individual getting the fuel rods?
That would be the fuel handler himself, yes.
Okay. And then there's support people beside the fuel handler.
So you've always got a fuel handler, he's got a peer check that's with him, and then you have a licensed senior reactor operator to authorize the fuel moves that are occurring.
Wow. So is there like a physicist somewhere? Like, is there like a really smart nuclear physicist around the room somewhere?
Well, there are nukes that are watching all this, but they're in another
That's what
room.
they're called, nukes?
Yeah, we call them nukes.
Okay.
Referred to people as nukes that were just in the Navy, and I think a lot of these guys were people that were in the Navy and later joined the civilian workforce. I am not one of those people. I don't have any naval experience. More than half of my coworkers did. Though the term of physicist, as far as like a reactor engineer or a nuclear engineer, the term physicist isn't really used because, I mean, there's not any like pure scientists per se. There's a term, health physicist, which is a more of an analyst type role for radiation protection, but you typically don't see scientists at a nuclear power plant. I mean, it's heavy industry, power generation. You don't really have like experiments or anything like that going on where you would have a physicist or any other forms of pure scientists.
Engineers, and they're in another room outside of here. They just stay, limit their dose that they're receiving, right? So,
I see.
So they're in
yeah, when I was in the engineering department, I didn't really get out into the plant as much. It just wasn't part of that job description compared to, say, being in the operations department.
To them later, but they're in another room over there and they're watching all of this, and they have worked with our corporate fuels guys to figure out what the appropriate way to shuffle the core is.
Gotcha. Okay. And so these people over here, if you'll look at my camera screen, those people just went into the C zone. You call it the C zone. That means contaminated?
Yeah, contamination zone, that's correct.
Okay, so somebody's coming out. So he's about to come down and derobe. What do you call the act of taking off your? Someone handed him something.
Yeah, well, we had to get something into the C-zone area, so he passes what's in. And once it goes in, it's okay, but they can't take it back out.
Yep.
Okay, I noticed the bridge just moved.
Got to be evaluated and deconned.
And what is happening now? So is he's at the reactor itself?
Yeah, it looks like he's going down to get a fuel bundle at this point in time in the core. He probably has one latched on. He's coming right now through the cattle chute.
Oh, he can
And
go
then-
straight through.
Yep.
You call that the cattle chute?
Yeah, it's just like just a generic term that we
It's a
utilize.
gate?
It's a gate that we can come through, and
Those gates. All right, so this was a lot simpler than the plant that I worked at. That it's just this one little canal that connects the spent fuel pool and the reactor cavity, because you would have to go through another canal, then transfer through the fuel transfer tube, just because it was in two separate buildings. But in a way, this looks a lot nicer, actually. But again, the trade-off is having 3 units right next to each other. You're just going to have that much more robust of a design for your containment structure.
he'll have the fuel at the end of that crane, and then he'll put it in the appropriate location in the spent fuel pool.
So what is the coordinate system for where the fuel is located?
There's a map down here I'm happy to show you.
Yeah, I'd love to see that in
It's
just
like playing a game of Scrabble.
a second.
Yeah.
I want to watch what he does here real quick.
So they'll get over the location that they want to go, either in the core or the spent fuel pool. The bridge will automate to where it's supposed to be at, and then he'll call out the core location or the spent fuel pool location that they're at, and then his peer checker will agree with them. They'll lower it, and before they latch or unlatch, the SRO will give their authorization that it's appropriate.
I actually see the hole he's about to. Do they light up the holes where they're going?
There's some lighting down there so they can see where they're working.
I can see what he's trying to align to.
And depending on where they are in the refueling portion, they'll sometimes adjust the lighting just so it'll be easier to see.
Here's one of our refueling SROs leaving right now.
Should we talk to him?
Sure.
Sure.
Hey, Sarah.
I just backed down that ladder because I saw you back down the ladder.
So, do you know why he did that?
No, why?
So, this sign right here says, hey, this is a ship's ladder. The incline isn't appropriate for you to walk up it normally, so you've got to maintain 3 points of contact.
That's.
So, he should have seen that you had all this equipment on you, and he should have said, hey, Austin. Did you say Austin?
Destin.
Destin, I'm so sorry. You should have said, hey, Destin, make sure you secure your equipment and maintain 3 points for safety.
So I'm kind of. What's your name?
Hi, I'm Sarah.
I'm Destin.
Nice to meet you.
Sarah, I'm kind of torn right now because I want to appreciate you for doing that, but also I can tell that you're kind of talking smack to Bill.
No, well, so...
No, coaching's coaching. That's how we
It's
take
coaching.
Well,
Okay.
No, it's up and
Feedback's a gift, a non-refundable one at that.
like 100%. This is normal.
Got it.
And if is this your first time at a nuclear power plant?
Yes, ma'am. 1 second. I'll turn this on. Sarah, what's your role at the plant here?
I'm a senior nuclear reactor operator, and I'm a fuel handling supervisor. I just came off of Unit 2's refuel bridge, and we're in the process of refueling Unit 2. We're in the process of 202 fuel moves and fuel shuffle number 1. I'm providing direct oversight of the fuel handlers. So there's 2 people here.
Ask her how long she had to stay up there. That's the real question. Gonna be something like 4 hours.
Where the mast is, and then there's
Before taking a break. I mean, obviously you work 12s, but
Allison, who's got the red gloves. She's my counterpart. She's just taken shift. So she's the fuel handling supervisor, providing oversight of the fuel handling, the fuel movers.
So she's in charge.
That's right. They're operating underneath her license in her direction.
So she's.
yep, so if they screw up, it's all her fault because she's the one with the SRO license.
Reactor operator.
She is a senior nuclear reactor operator. That's right.
Forgive me. What's the difference in just a normal reactor operator and a senior?
Different license.
You have a technical specification responsibility that you maintain, that the plant is operating within its license.
So the senior reactor operator is the supervisor or management role, and you actually manage the reactor operators that operate in the control room. Now, what she's doing is different, that she's over a team of contractors that are doing the refueling operations, but that can only be done by senior reactor operators. A reactor operator license isn't enough. And getting the license has its own set of requirements, and it's typically harder, because it requires everything that a reactor operator is required to do and then some. So it's just adding in the technical specifications, like she said, plus the necessary management and leadership skills that you would need for that particular position. And it is possible to get a senior reactor operator license without having been a reactor operator. I never had a reactor operator license. I went straight for senior reactor operator, and that's based on my education and engineering background. I was considered to be eligible to do that. Well, to essentially skip that step, it's what's known as a instant SRO or direct SRO, depending on who you talk to. There is also a specific type of SRO license that's limited to this refueling operations. I've known a handful of people that have had that, but it's less common.
So Sarah, you had to train to be a reactor operator.
That's right.
What's your background?
I went to Mississippi State. I was a biology chemistry major, and I joined the National Guard. I deployed to Iraq. I came back, and my husband had come to Huntsville, so I transferred all my hours to UAH. I finished up my degree there.
In what?
In biology and chemistry. They were not hiring in Huntsville, so I decided to work on my PhD in biotechnology. And finally, TVA came for a job fair, and they were not looking for engineers. They were looking for biology chemistry majors, and so
interesting.
I'm here at TVA as a chemtech, and
a PhD for chemtech. That's interesting. Most people I've known that have PhDs, like, you don't see a lot of PhDs hired at a nuclear power plant. And mainly, I think part of it is I think a lot of PhDs just wouldn't want to work there because it's different. But that's awesome. It's cool to see someone with that level of educational background essentially do this kind of job.
I rated 16 years here at Browns Ferry, just in February. And so I worked for 9 years as a chemistry technician. I became a supervisor. And then 3 years ago, I went to transition into operations, which is a 2-year training program.
Yep, that's typical, especially for someone that wasn't in operations.
A senior nuclear reactor operator for about 18 months.
That's awesome. Well, congratulations.
Thank you so much.
That's fascinating. Someone that's very experienced but hasn't had the SRO for that long, and that's a stepping stone for her career right there.
There's a lot there.
There is, yeah.
And she would have absolutely exceeded the requirements to do the direct or instant SRO. You really just need a bachelor's. You don't need a master's or PhD for that.
So how long will it take them to do the refueling in total?
Well, we break it up into small pieces. Browns Ferry actually holds the record at one point in time for a refueling outage of taking the vessel apart, changing out, putting it all back together. I think maybe 12 days. Bill can correct me. We have that.
That's impressive.
We have the record on that. However, this refueling outage is scheduled for about 30 days because when you shut a nuclear reactor down, you had to do all this maintenance that you can't do while online.
Yep.
So imagine driving your car. You can't change the tires while driving your car. You got to stop it, lift it up, change out the tires. So we're doing all that maintenance that we can't do while online.
Okay, so that one's an outage.
Yes.
But this one's operating, right?
100%.
It literally is 100%.
Literally 100%. A nuclear reactor loves being at 100% and just hot, fast, and normal all the way.
And what's interesting is the scope for these outages are defined. I mean, there's various levels of scope definitions, sometimes 2 to 3 cycles ahead. And a cycle at Browns Ferry, like they said, is 2 years. So if you're trying to plan for something, say, 4 years in advance, you might be able to just squeak it in if it has to be done during an outage.
So I would have thought that I would be seeing something come out of there, but it's got a cap on it, right?
Well, so this is the spent fuel pool. Over here, where all that stuff is on top of it, are the shield blocks. And the reactor's kind of hidden all the way down there inside a dry well, and then the reactor head on top of it. So this thing right here,
the big sphere,
the big dome.
Okay.
That is the dry well head for Unit 2, and around the corner is the reactor head for Unit 2.
Have to disassemble all that
that would
every
sit
time.
inside of it.
But we're not going to see that because that's in the C zone.
I don't know. Bill might be able to take you along this way in the clean area, and you might be able to get a view over there.
Okay, interesting. So the fact that you're refueling is the one time you get to see the reactors open. This is a very special time that we're here.
That's right. When you are riding this bridge and you're looking down into the vessel, it's really, really neat. It's just there, and you guys are here at a great time. The water's really still. We're not doing a lot of inspections right now, so you're going to have great views down into it.
Really?
Yes.
Do you have any recommendations of things I should look for if I'm going to get on the bridge?
Oh, I mean, you're going to look for the blue Cherenkov radiation. You're going to watch for how the people operate. So don't just think about the mechanics of it. Also think about how you're seeing people operate, how we work together as a team to make sure.
Yes, it's very different. The whole idea of peer checkers, step verifiers, independent verifiers, you don't see this anywhere else.
Safe, error-free,
and it's overkill.
Making sure communication is crisp and clear.
So the communication is very clear.
Always.
It's kind of like aviation where
And yeah, it is kind of like aviation. And the whole error-free mindset. Now, it's a term that's existed throughout the industry probably since the days of Admiral Rickover. But it's this one thing, I've always had questionable thoughts about it, because having error in, just the word error in your step, even though it's error-free operation within the step, it just seems like it's very negative. It's like you're always preparing for the worst. I mean, and that is part of the job, but it carries a bit of a better not screw up kind of mentality that has good intentions, but can be a bit overkill sometimes.
A call and a call back kind of thing?
We actually have three-way communication.
Yes.
You send it, they say it back, and you tell them if it's right or wrong.
Really?
That's
yes.
right.
Okay, that's awesome.
Yeah.
And
for everything, especially in the control room, and definitely on the refueling bridge.
The name of the lady that's the senior reactor operator?
That's Allison Vagoya. She and I actually were in class together, and her background, she's an engineer. She's providing direct oversight of the fuel handlers.
That's fairly common. They'll send a lot of freshly licensed people to do this job early. And when I say early, I mean relatively early in their history of getting their SRO license. I'm glad I didn't have to do it again, because I just didn't want to hold it that long. It's a lot easier to get relief when you're in the control room versus when you're here on the refueling bridge. Maybe they for all I know, they do it differently. They stagger it every 2 hours instead of every 4 hours for when you and your partner hand off. But yeah, I had my senior reactor operator license between 2017 and 2022, and I'm glad I never had to do this.
And so there's Bill's here. He's going to tell you everything about it, because Bill did my job before he changed into being a supervisor of INC. So he'll be able to tell you everything. He's ridden that bridge. He's done this job.
I have ridden the bridge, though, so I got to experience the fun part of it.
Allison's going to be providing oversight to make sure that we have no mistakes.
And that's mainly, you're required to ride the bridge as part of your licensed operator training. The plant I worked at, it was even required for reactor operators, which is interesting because reactor operators don't go there. Just senior reactor operators do.
Okay, so Sarah, I've got a question for you. So you've done all the stuff you've done. You're a reactor operator.
That's right.
You've moved fuel rods. Are you comfortable with a nuclear reactor in your backyard here in North Alabama? Like, do you feel safe?
100%.
Really?
I have 3. I take.
That's the best response to that. Yeah, I've always felt quite safe around nuclear reactors.
When people are like, oh, there's a nuclear power plant, where? I'm like, oh, southwest of Athens. Do you like having electricity? 2 million homes. Like, I roll up into some place and they're like, what do you do? I'm like, I'm a senior nuclear reactor operator. You're welcome for the lights.
Yes. Yes. File out your tax returns. What's your job? You're welcome.
But you feel like it's all safe? Like, people make mistakes, and I've something I've wondered about, like if this is a man-made system and people made this and people do make mistakes, how do you know it's safe? Is it because of the procedures or operations, or why are you comfortable with it?
So we sweat the small stuff. I just corrected you on how to use a ladder. Did you think
She did, yeah.
Did you think that you were going to get told about a ladder? But that's it.
Awesome.
And we're always watching out for each other. Bill's like 3 levels above me, but he takes it as a piece of thing of I should have looked out for someone like that.
So it's culture.
It is.
It's culture. It's also robust design. So this is all about correcting the small stuff, like she said, but it's also so the design. I mean, it's a robust design boiling water reactor. That has multiple redundant safety systems to prevent you from the bad stuff that everyone's afraid of, such as core damage and fuel damage, or accidental radiological relief. It's the engineering robustness plus the culture is why it's one of the safest, if not the safest, industry in the world.
One of the great things about nuclear power is being able to raise concerns without the fear of retribution, and us knowing that we live here.
Yeah, there's no retaliation.
This is our home. We had to take care of it.
Tell me more about that, being able to raise concerns without...
It's called SCIWI. It's the safety conscious work environment. It's something that the nuclear power NRC mandates that we have.
Yes, and you get SCIWI training all the time, regularly, not just from the Nuclear Regulatory Commission, but the Institute of Nuclear Power Operations, which officially they're a consultant group, but unofficially they're essentially a second, much more harsh regulator than the federal government.
If we had any concern, we can always bring it up. And if you don't feel that anyone is acknowledging your concern, you go to the next level.
Every nuclear power plant is required to have an employee concerns manager.
You have to do it anonymous. If you had to go straight to the NRC, you can.
Yes,
but
you can.
No one is going to turn you away on a...
The NRC also have an office there. It's the resident inspector, so you can go straight to their office. So yes, the federal government has an inspector on site all the time.
Conscious on a safety concern.
That's awesome.
Right.
Thank you, Sarah.
You're welcome.
Yeah, and you went to Mississippi State?
I did.
You didn't smuggle a cowbell in here anywhere, did you?
No, but it would be great if I did.
Okay, great.
So this is your core map, and it's got every fuel bundle location in the core. You can see the crosses. Those are where your control rods normally sit at.
How many fuel rods are there?
764 bundles in each core.
764.
That's right.
That is...
Yeah, bunch of little ones. Again, the planet I worked at had 193 bigger ones because it was a pressurized water reactor rather than a boiling water reactor.
way more than I thought.
Yeah, there's a lot.
That's way more than I thought, okay? And you said the crosses are the cruciform control rods.
That's right.
Okay. And so okay.
A lot more control rods. Basically, it's around this. It produces around the same amount of power, but it's a bit more spread out.
This rod. How do I say this?
It's just an XY and XY map, right? So that'd be rod 4732 is what we call it.
4732. And what is the unit?
Just core location.
Oh,
it's an arbitrary unit that we put up of map.
It's a grid. It's as arbitrary as playing a game of Scrabble. It even kind of looks like a Scrabble.
I see. Got it. Okay, so when we're out there, what are we going to see? Are they going to say, go get this rod and put it in the spent fuel?
Yeah, they'll say come into core location 1740, and then you'll have another guy agree with the location that they're going to go to the next control rod or the next fuel bundle. Then they'll go over that location, say we're on top of location, and they'll lower the mast to sit on top of the fuel bundle. Then they'll look to make sure that the fuel bundle and the location, the serial number we showed earlier, all that matches. Then once everybody concurs, the SRO will say, I agree, you can engage on the bundle. Then they'll engage, bring the bundle up, and then they'll talk to the next location they'll go in the spent fuel pool.
So who is doing that? Like, who's keeping up with what rods are moved when?
So there's a FATF that we have. There's this is what Jessica's keeping track of. They have a manual one on that bridge.
Okay, so she's the step verifier here, is what they call this outage position at the plant that I worked at. Note the official copy that this is the one that is going to go into the records for the plant. And yes, still uses pen and paper.
They've also got a
Yep, and all those initials carry weight for all the operators and verifiers, because this stays with the plant for the life of the plant as a legal record. No pressure.
The bridge is automated now, right? So there's actually...
This information is loaded into Worldtron.
Yeah, so there's a computer on the bridge that'll help utilize to make sure that it's...
So Jessica, I noticed, can I see that mic for just a second? So these are fuel bundles moving from one location to the next?
Yep, it's showing them that they're going to pick this up from a reactor location, and then they are taking it to a location in the spent fuel pool.
So that's a location that means something to you.
Yes, this is where that fuel bundle, this is its home. And this is where it's going to rest.
I see. And it'll be there for 2 years or something like that.
Not necessarily. It could be going back to the core. It's just on this first fuel shuffle. This is where it's going to rest. It could be picked up and taken back at a later time.
I see. Okay, Bill and I are about to go up on...
And that's all going to be set by the core design team, which is typically going to be a corporate reactor engineer function as far as the core designers. They would design the fuel layouts for the entire fleet of nuclear power plants.
Bridge, which is a pretty big deal. He's getting our work order number.
Scroll down to RWP 92.
High red area, yellow.
Right?
Yep.
6250, we'll hit yes and yes.
All right. So that reset my dosimeter.
It did.
Yep.
Okay.
It's a different job, so that dosimeter is per work order. The other one that he has, the DLR, the dosimeter of legal record, that one stays active. So it reset it so it can take in the dose from this specific job. So the 0.1 millirem from the other job doesn't count toward this.
All right, then we'll come over here and we'll get dressed out.
I'm constantly thinking about where I set things down. All right, so I'm getting dressed now, right?
Yep.
It's good. Maintaining positive control of not only yourself, but of all of your equipment.
Thank you.
Destin, we don't wear our hard hats inside the C-zone.
Okay.
Where we're going, so you can take that off right now while we're getting dressed.
And that would have been some sort of evaluation was done by the safety team to say, hey, this hard hat is more of a hazard of falling in the reactor cavity than any possible head injury hazard in this particular zone. So a risk assessment was done by the safety team to determine that.
Thank you. Do I need the ear? I'm good without the ear pro for now?
Yep.
Okay, great. Christian's a smart cookie, isn't he?
Well, they all are.
Man, I wanted to... Everything got itchy all of a sudden.
Well, you got a couple more seconds. You can scratch yourself.
Can I scratch?
Yeah. You're not in the C-zone yet.
Oh, great.
Yeah. Scratch away.
Everything got itchy. So how do I look?
That's real.
Then
That's
hood over the top of this?
Yeah, hood over the top. You look pretty good. I got my dad. I got my TLD. We're good.
My TLD? Okay, cool.
All set to go.
It's all gone.
Validate. You ready to go?
Yep.
There it goes.
Validate y'all are on RWP 25200092.
Correct.
And your dose alarm is?
250. Dose alarm is 60. Dose rate alarm is 250.
Dose rate alarm is 250 millirem per hour.
That's correct.
So you are good to go.
When calling out numbers in the control room, it's important to say parameter value trends. I'm glad they've incorporated this for the radiation protection as well.
Thank you. So I need to take it out?
No. So it's right here against your chest. So what you'll do is you'll just...
Okay.
When you get the green light, you go through.
Roger that.
Just like that.
Yes, sir.
Okay.
So y'all go try that out.
You ready?
I'm ready.
All right, you got the green light, so you can progress.
I'm going to hand this to you, Bill. Okay. Thank you.
If y'all have any questions, we can definitely meet people. And there's another radiation protection technician inside the building.
Actually, I'll give that to you.
Yeah, when you go into these zones, you're going to see radiation protection technicians. There's going to be rovers that go around, and then there's some that are to the specific zones where a lot of the activity is going on.
Okay.
Yeah. Thank you. Thank you.
All right. You are in officially a C-zone.
We're in the C zone, the contaminated zone.
That's right.
So this is the top of the reactor?
Make sure you hold a handrail.
Hey, hold the handrail, yes, sir.
This is actually the dry
Way to keep them straight.
well right here. This is the drywall cover. This right here is our FME buffer zone, right? These are our FME guys that are going to help us out to make sure that we can get on inside.
These are the monitors that keep a log of everything that you take with you when you go into the FMEA zone.
That FME buffer zone.
How y'all doing today? Doing well.
How are you?
Good. And then get y'all to sign this. Yes, sir. Please write as legibly as we can. Card and gloves.
Do you remember me saying the foreign material exclusion people wanted to make sure I didn't drop anything into the reactor?
Yes, this is
Well,
important.
to do that, it required a lot of straps attached to a lot of gear attached to me, and we even had to wrangle another guy to come over and help us make it happen.
Yeah.
Take the other one? Yeah, I'm gonna take this.
I've never seen anyone try to bring a camera into any FME zone before. This is a monumental, someone who is essentially a visitor coming in, and I really appreciate what he did. I based on everything I've seen throughout my career, I never thought I would see this happen. This is quite remarkable.
What's your name, sir? Philip.
I'm glad all these FME monitors and control personnel are willing to help him with this sort of stuff. That's great, because that would have been a convenient excuse just to tell somebody, no, that you can't come in here. It's too dangerous. The risk of dropped objects is too high. But they worked with them.
Phil's been with us for a long time up
Has
here.
he?
Now, by signing this paper, y'all acknowledge all the rules and requirements of the FME zone, correct?
Yes, sir.
Y'all have no loose jewelry, no earplugs on. You have chums on your glasses.
I do?
Yes, sir.
Everything's
All right.
tracked.
Now, when y'all go in there, y'all understand everything that is going on the bridge and the work that's being performed.
Yes, sir.
Yes, and these are to remain on your wrist at all times.
Yes, sir.
All right, y'all understand everything you're doing to mitigate FME risk.
Yes, sir. I took the training this morning.
All right.
Yes, sir. Brian, right?
Yes, sir.
Thank you, Brian.
What we do once they get back.
I like how polite he is to all of these large numbers of support staff that you need to make this happen. That's just a class act.
Over the spent fuel code, we'll acknowledge them, let them know we're coming in the bridge, and they'll tell us when we're coming.
Okay, Philip, you're gonna be with us.
I'm going to hold this, and I'll hand it to you.
It's recording now. Just letting you know.
Oh, you going to put it?
So feel free to just point at places. If you find something interesting, feel free to point it, or don't.
Before y'all walk in, all you need to do is at the bottom of your feet, make sure there's nothing stuck there.
Yep.
Yes,
that's
sir.
important.
Tell me when you'd like to do that.
Right before you walk in, it's perfect for me.
Okay, so we're not in the zone yet.
We are in the C zone. We are not in that foreign material boundary.
Yes, there are boundaries for all sorts of things, and yeah, I'm used to seeing yellow or magenta as anything to do with radiation protection or contamination. Orange, I've seen white signs for FMEA zones. Or I guess FMEA zone is the plant I worked at. It was called FMEA, Foreign Material Exclusion Area. I don't see any here, but there is also green I've seen as a color for plant status control to avoid bumped components. And some of these colors might vary depending on what site you go to, but there's a lot of information about which particular hazard is the greatest of concern. And of course, right when you get above the reactor cavity, it's going to be foreign material exclusion.
Different levels.
That's right.
Yeah. Okay.
He's going to go over there and put it in the cleaner. Once he puts it in the cleaner, we'll have about a 30 second window to get on the cleaner.
Philip, what's your role here?
I'm a OST Boilermaker.
A Boilermaker?
Honest service technician.
He just talks like it's no big deal. This man disassembles the reactor vessel for us.
So he knows what he's doing.
He knows exactly what he's doing.
That is some highly skilled craft right there to do something like that, because that is a big piece of equipment. And there's a whole art and science towards detensioning something like a reactor vessel head. It's quite a marvel.
He's humble too.
He is very.
A lot of these guys
All right, Brian.
are. The best guys typically are.
Good. Good. Enjoy yourself, sir.
Philip's enjoying this. So that's the reactor right there.
That's the reactor. We got waved
you.
on by the SRO? Go ahead, Destin. You go in front of me.
Yes, sir.
You got the chain? Thank you.
Hello. Doing well. How are you?
On the bridge.
Thank you.
We're at the cleaner.
Where would you like me?
Staying over here away from everybody.
Yes, sir.
So you're in a really
Makes
unique
sense.
spot. I have never seen anybody, never taken anybody up here for this particular instance before. I've never seen this happen before.
This is a big deal.
I've never heard of something like this before. It really is.
It's a huge deal. So right now you're over the spent fuel pool. You can see we have coordinates. If you really look carefully, you'll see on the walls a map of where we're putting the spent fuel pool racks.
Over there.
Yeah. Just try to be careful not to lean over the rails
pool.
with.
Can I swap with you, Philip?
Maintain positive control of your body parts.
So we just do it. How you want to do this?
Hand to me, and I'm gonna hand you this, and I'm gonna stay with you.
Okay.
You just keep that one around your wrist. I'll keep this one, and I'll stay with you.
Yes,
Yeah,
sir.
got everything around the wrists, and so when you transfer from one person to another, it's a solid plan. They made a plan for material
I'm gonna look
exclusion.
at. We're pulling one out now.
No, they're washing one.
Now, hey, listen, that bridge will jar a little bit when it moves.
You're telling me it's going to move. Don't freak out.
Yeah.
But when it does move, hold on to everything because I don't want you to think.
Tell me when it's going to happen, please.
I can't promise I'll know that.
Okay.
When that fuel bundle comes up out of that, when that's sticking down in there, when it comes up out of there, it's gonna move here in a second.
He's moving the bundle.
Now these are a bit smaller, but the ones at the plant I worked at, fully loaded, were a little over a ton. These are, I mean, they're going to be proportionally less than that, but still quite a bit of force that we're talking about here.
When it comes up out of that hose, see it coming up?
Oh my goodness! I can see the Cherenkov.
Yeah. It'll come up to a safe height, and then they'll make it.
Lovely blue glow that you see when particles travel faster than light in water. You can't travel faster than light in a vacuum, but you can travel faster than it in water.
Put it in the fuel rack.
It's free right now. I can see it's out of the hole. Philip, was that a new?
The bridge speeds are going to be restricted as well, interlocked, based on how close the fuel assembly is to other fuel assemblies. It has sensors on there that you can only go above a certain speed once you're clear over open water.
Rod, or what was that?
That is an old one.
That's an old rod. How do you know?
Let me get on the other side.
You can tell how it's burnt. See the glow around it?
Yes, sir.
See the tops? They're shiny over there? Them's new ones. You can tell the difference because they'll be shiny like that all the way down.
Oh, okay. So
One thing about fresh fuel, there's no hazard. You can touch it, you can take it out of the water. The hazard is not the uranium, it's the fission products, and that is why these needs to be done well underwater. But new fuel receipt, which happens months before an outage, reactor engineers will inspect these outside of the water. I mean, they show up in big specialized containers, and they're typically brought in by truck.
they're shiny, meaning
They're all new fuel rods.
those are brand new.
Yep.
These are all old. Well,
There's no fission products in a brand new fuel rod because no fissions have occurred yet.
a lot of this is empty, right?
Yes, that's where they're going to bring it out of the core and place them there.
So that blue glow I'm seeing is the Cherenkov radiation.
That is correct.
That's correct.
Yep.
I've never been more aware of my camera
I'm glad.
and dropping it. Okay, what is he doing now, Philip?
He puts and place it in a fuel rack.
He's putting it in the fuel rack.
Yep. See it going down in there?
Yeah,
Most people think the radiation's green, but it's, as you can see, it's not.
it's blue.
Yeah.
You think The Simpsons for that one.
Philip said most people think the radiation's green, but it's blue.
On all the shirts, it's green, fluorescent green. It ain't really true.
Philip, what's your story, man? I'm on level with you, man. You got an Alabama accent.
Yes, I do.
Where you
Been
from?
here all my life.
Been here all your life?
Yeah.
Okay. What just happened, Philip? They released
Just
it?
delatched it.
He released it, now it's coming up.
Is that a camera on the end of it?
It is. We got two cameras.
Are we going to the reactor now?
Yes, we are.
Can you turn around this way, Bill, and just face that way?
Yeah, let me.
Right here.
Let me come.
Oh yeah, over.
Yeah, swap cameras with me.
Swapping cameras again.
I can't tell where this is pointing, I apologize.
That's okay.
So right now we're centering up to go through the cattle chute in order to get into the core.
Cattle chute. They have a name for everything. I've heard reactor containment buildings referred to as just a big round thing. But it's just a canal.
Holy cow.
You are now officially over a reactor vessel and refueling operations.
Oh my goodness. So that's a nuclear
I never get tired of that.
reactor. And they're just sitting there.
Those guys are doing their inspections with the camera. That's what they're working on.
Gotta do
They're
your
trying to get a camera down to inspect the welds on the
They're doing
on
what?
the vessel. They're working. We call it IVVI. They're doing inspections of the welds and all that type of stuff inside the reactor vessel barrel.
Really?
Let's get out of
There's a
Allison's way.
whole lot
Sorry,
of inspections that you can only do during an outage.
So now, Destin, they're going over a core location. They're going over a core location to pick up a bundle.
I'm gonna stay right here unless somebody tells me to move.
I already appreciate Destin's reverence for the plant. He's well, there's a reason why he's allowed to do this.
How is that?
I'm sure that was part of it.
I'd say probably somewhere between 80 to 100 feet of water.
So earlier, Sarah had talked about the importance of communication on the bridge. And I have been in environments like aircraft before where they do this call and response or the positive communication, but I didn't expect it the way it was happening on the bridge because there were so many people spread out and they all had different tasks and they were all being very clear about what they were doing. So it's like there was this tone on the bridge that was different. And I could feel that I was in the way, but I was off to the side. So they were like letting me be there with Philip and Bill. But at the same time, you could just feel the professionalism of the people around you. And of course, I wanted to be that way because we're literally moving nuclear fuel.
I mean, the term reverence is not a misnomer. I mean, it's very much a ceremony. It's like being in a church or a temple or something and people are doing something with the utmost reverence and respect for the amount of energy you are dealing with here. And it's one of the remarkable things about this industry that you really don't see very much everywhere else. Maybe a little bit in aviation.
In a reactor, which is awesome. Okay, this is footage from inside the pressure vessel. The reactor core is just down below us. This is what the team is actually doing. These are video cameras that are in the water with the nuclear reactor.
Interesting they're doing it at August. First I've noticed this. Yeah, that wouldn't have worked at the plant that I worked at, but maybe in the way that you stagger 3 units, that's where you end up. But yeah, at the plant I worked at in Texas, taking apart a reactor in August, man, that was not typically recommended.
It's not running right now, it would be boiling, but this kind of blows my mind that we're even able to see this. Let's take a look at what they're doing. Browns Ferry's in the middle of a nuclear refueling outage, right? So they're moving fuel rods. This thing is called the refuel bridge crane, or sometimes called the main hoist. This person is operating the hoist, which can go up and down and rotate on its axis. The hoist is connected to the whole bridge, which can move in X and Y. Now, at the end of the hoist, there's a couple of cameras and a grapple. The first camera is offset just a bit, mounted behind the grapple with a bit of a wide view. It offers context for the operator so that they know exactly where they are. The second camera is right on the end of the grapple, so the operator gets a close-up view of exactly the thing they're picking up, and they also get feedback on how the grapple is gripping the item. Let's watch them actually grab a fuel rod. Using a computer-controlled indexing system, the mast is automatically moved into the position that they specify with some type of coordinates that they typed in. They then fly in and they use the coaxial camera to verify they are where they want to be. They then approach carefully and look closely at the fuel bundle. Using the camera at the end of the mast, they then verify the serial number on the top of the fuel bundle handle, and then once they're satisfied with that, and everything's correct, they then lock onto the handle with a grapple. After they verify they have a solid grip on the fuel bundle, they can then extract it. They can then do any number of things with the bundle. They can use other cameras to inspect it. They can move it, they can rotate it, they can even put it in an ultrasonic cleaner. For every 4 fuel bundles that are in the
On the ultrasonic cleaner, at least at the plant that I worked at, you didn't typically do that every outage. It was within a certain periodicity of the individual fuel assembly. But every now and then, that's how you clean fuel assemblies.
reactor core, there's a control rod in the shape of a plus or a cross. It's called a cruciform control rod, and it's inserted from the bottom of the reactor. That's what stops the reaction.
And that's specific for a boiling water reactor. In a pressurized water reactor, the way you put it in is after the core is fully reloaded, then you put in the rods as inserts from the top. And they have latching mechanisms that you would put on when you put the head on the reactor vessel itself. It's quite the intricate process. I want to say this looks easier in the sense of doing it from the bottom versus the top when you're trying to put the head back on. But either way, it requires a lot of specialized outage personnel to pull this thing off without a hitch.
These control rods are so long, if they ever remove more than 2 bundles, that control rod could wobble. So to control this wobble, they have these things called blade guides. Anytime there's 2 or more bundles removed from a certain grid, they insert these blade guides to hold the control rod in position. If you look down into the core, you can see these bright, shiny spots.
There's all kinds of crazy tools. There's also essentially shoehorns for getting the fuel assemblies that are kind of on the ends. It gets
I thought those were new fuel rods, but they're actually blade guides. You'll notice that they're always in sets of 2. The operators say that inserting a blade guide is kind of like wiggling a pair of pants and trying to get the 2 legs to line up with 2 holes.
So there you have the difference. In pressurized water reactors, you're putting on shoes. In boiling water reactors, you're wiggling a pair of pants.
Pretty hard, they say. Now, while all this fuel rod movement is happening, there's this other team that Bill told us about, the IVVI team, which stands for In-Vessel Visual Inspection Team. They're using a bunch of cameras on jib arms. You can one of those cameras here, you see it's got a long arm and it can articulate. They use these cameras to closely inspect the mechanical integrity of the reactor vessel and any of its components. Watching them do this is so awesome, and it made me really respect the process that's going on here. Everything that's done has a crazy attention to detail about it, and it's clear that these nuclear industry workers really care about getting everything exactly right. Now that we understand what we're looking at and we know what they're doing,
and with stuff like this, if you get it wrong, it's going to bite you in the rear later on when you start having issues when you heat up, repressurize, and take the unit back online. So this sort of stuff is very important, and it's all about being proactive.
Just watch the team in action. They're about to take a rod from the reactor core, and they're going to put it over in the spent fuel pool.
I want to scratch my nose so bad.
Don't do it.
Here's a common nuclear industry joke. Where does Mr. T put the bad neutrons? In the spent fuel pool. There's a lot of dad jokes in the nuclear industry.
I will not. Philip, what's he doing, man? Did he just grab it?
Yeah, I think he's got one on there. Yeah, he's coming up.
Is that a light in the pool?
Yeah, we have cavity lights.
And he changed the orientation?
He did. He just rotated it back.
Does orientation matter?
Yes, orientation matters.
Why does it matter?
Oh, yes.
Because when you put 4 in there, you've got to have them orientated right.
And each fuel assembly is a little different than the other ones. So it's all about having a even neutron flux and heat flux profile once the reactor is started up and back up and running again. That's where the game of Scrabble comes in.
I can see the shrink off. So, Philip, that's called the cattle gate we're going through?
Cattle chute, yes, sir.
Cattle chute.
Yep.
Cattle chute. Got to make it even more Alabama.
Wow. Is that a hot rod?
It is very hot.
That's a very hot rod.
Yes. Back up out of the water, would no longer be here. None of us up there.
Really?
Yeah, you start getting it towards the surface, you're going to see area monitors go up significantly, and the evacuation threshold would be way before that thing comes fully withdrawn from the water. Also, there's interlocks in place to make it impossible to fully withdraw these things out of the water.
So the water's protecting us from the neutrons right now.
At least 6.5 feet or below.
So neutrons are not the primary hazard here because they're only a hazard when the reactor is operating. It's going to be things like beta and gamma radiation because, again, it's the fission products are the primary hazard of concern here. Neutron dose is only a concern when the reactor is actually operating because fissions are maintaining the neutron dose. A free neutron by itself, its half-life is only 15 minutes.
What they're doing now is verifying the location where they're putting it. They read the rack number. You can say they put it in golf. The big golf.
Yep.
Well, golf 11 is where they're putting it in.
Oh, I see.
See the numbers on the racks over here?
I see the letters, yeah. I'm going to watch him drop it, and then I'm going to look at those letters.
Yeah, numbers over here, letters over here. They keep up with the location where we put them. When we do a fuel dry cast, we'll put them in and know which ones to get.
They'll sit in the spent fuel pool for several years before they're decayed off enough that you would put them in dry cast storage for long term. And by long term, I'm talking at least a century.
So that was Golf 11?
The fact that he's able to capture all this.
So we were in Golf 11.
3 back. 13, 12, 11. Yep.
So now he's releasing.
Yep. Now they'll come up to a safe location to get back to the cattle chute.
And on to the next one.
So we're in the refuel pool, and we're going to the reactor, right? We're going through the cattle chute now.
For most of my life, I
all slow, methodical, but like clockwork.
Understood nuclear power, but it was here, standing safely over the top of an open nuclear reactor with fuel in it, that I started to realize something. One of the main reasons people fear this technology is they don't understand it.
That's why people fear anything.
Everything was starting to make sense to me, and with that, I was starting to run out of things to be afraid of.
Thank you, gentlemen. Thank you, Allison. Don't want to hit that button.
What is it, the E-stop?
The E-stop.
Emergency stop.
That's awesome.
There's just a few more important things I want to show you, the first of which is in the equipment storage pool.
So what is this over here to the right?
That's your steam dryer.
And what is this?
That's your moisture separator.
Now, how does a moisture separator work?
Well, so it's essentially as the steam boils, it's got cylindrical, tortuous path for the steam, right? So only the superheated steam is going to make it out of the steam separator, and the remaining, I guess we'll say condensation, if you want to call it, the water, moisture content in the water will drop back down to the...
So it's almost like a still, but just for steam.
That's right.
Really?
That's right.
But it uses some of the energetic properties of steam to separate it.
Yeah, all it is really a big hunk of metal and lets the steam do the work.
Oh, really?
Yeah.
I see. Wow.
Yep, just provides a bunch of little steps through chevrons and little whirly thingies. Yeah. And the main reason for this is you want high quality steam, and by high quality, very little moisture content. One, it's more efficient for your thermodynamic cycle. And 2, high moisture content at that high pressure and at that high temperature could impinge on the main turbine blades and potentially damage them over time. So it's about more efficiency and protecting the asset, the moneymaker, was what a lot of people in the nuclear industry refer to as the turbine.
Why is it in the pool?
Well, because it sits on top of the reactor.
Oh, that's right.
Because we boil inside the reactor.
This is another unique boiling water reactor thing. The steam separators are within the steam generators, which is not the same vessel as the reactor vessel. The reactor coolant goes and heats the steam generators, boils the water. Just a separate heat exchanger vessel from the reactor. The plant I worked at had 4 steam generators per reactor. But this one's a much bigger one that just goes over the reactor vessel.
And then we use that to make our steam high quality. And then we get it through the dryer and then out to the steam lines.
So okay, I'm starting to understand. I had not considered this part of it. So you make hot water in there in the reactor. Yep. It boils,
yep,
and it goes up.
Yep.
When it goes up, it goes into that.
That's right.
Mm-hmm.
And then is that like a heat exchanger? Like it bumps? I'm noticing pipes.
No, all they are like cylindrical pipes. There's no
ceiling.
No,
it's
no
just to make it go in a direction.
That's correct. Okay. It's a tortuous path for the steam to go through in order to allow the moisture content to drop.
Yep.
I see. Okay, and so then that hot water gets circulated out, and then that goes to the turbine, right?
Steam.
The steam.
The superheated steam.
Yes. Yeah. Okay. So because the top is steam.
Right. You want as low moisture content as possible, right? Going to the turbine.
This gentleman come through.
Just a big dryer.
And I mean, it's not superheated very much. It's going to be just above saturation, just as it naturally flows out of there. But it's not going to be a huge pressure gradient we're talking here, or a huge temperature gradient, rather.
Big dryer filtration?
It comes up, it gets the steam drier and drier.
Really?
It was now time to exit the contamination zone and make our way over to the turbine, which I was super excited about. But first, we had to have all our camera equipment examined to make sure that no pieces had fallen off while we were on the bridge. While they were doing that, we took off our radiation protection clothing, and after that, we had to sign out of that RWP for the bridge and back onto the one that we had been on when we entered the plant. We then had to do some radiation testing to make sure we were clean, and Bill took us down and
essentially a combination of friskers and those monitors you see there to make sure that you're not contaminated.
See the turbine.
Back we came and then go in another elevator.
And you still have the gun.
You don't want to lose that.
Would you like to carry it?
No, not at all.
I would not.
So on our way over to the turbine, we had to go back through the room that had a lot of the control infrastructure for the control rods in it. We walked past that drain that we walked into when we went into the watertight door. We had to make sure we didn't step on the drain. And then we went through that watertight door and we ended up here.
Where are we, Bill?
We're on the turbine deck right now. And we're
turbine deck.
Yeah, we're going to show you what the main turbine looks like. Typically, this is inaccessible when we're operating, right? You couldn't go to any other units. But this is our main turbine.
Is it in pieces now?
This is the turbine?
That's correct. 3-stage turbine.
And it's not running right now.
It is not running, that's correct.
So the fact that we're here is pretty cool.
Yeah, I think so. You got your high pressure turbine and your 3 low pressure turbine stages.
So this is the high pressure turbine, right?
Similar type of turbine to the plant that I worked at, and I imagine a lot of power plants that produce similar levels of megawatts.
That's right.
What's it wrapped in?
Just lagging.
For what?
Just to keep it cool or keep it in case somebody touches it.
Insulation?
Insulation.
Yeah. What did you call it?
Lagging.
Lagging.
That's right.
Never heard it referred to as that before.
Cool.
Just insulation.
Following you, man.
All right.
So this is the high pressure side?
This is the low pressure side.
Low pressure.
We got 3 low pressure sides.
Wow.
High pressure being the one closest to the main steam line.
And so normally that thing's moving real fast, right? A lot of energy.
About 1,800 RPM.
So this is what keeps my lights on.
Yeah, this looks like the same turbine.
Is a lot for something this massive.
That's right.
So you have to
the one at the plant I worked at was actually on the roof, but it had additional layers of housing on the turbine generator building.
Because of rotational inertia, there's no way that you start with steam initially?
Yeah.
You don't have like a booster to get it going.
We have a jacking gear that will run it on. But
a transmission.
The turning gear, yes.
Effectively. Well, really the jacking gear just rolls. It's an electric motor that just rolls the turbine. So while we have steam getting ready to be applied to it, it doesn't blow the rotor. So
yeah, it's important to do that to maintain heating even. It's essentially just a really big hunk of metal, and you really don't want something like that to warp.
It's steam that rolls this turbine.
Wow. It's huge.
It's a lot of steam.
And so those lifting lugs are to take the top of it off. So is this a crane overhead?
That is, yeah. And some outages will actually expose all this and show the turbine and have the low pressure turbine available, and we'll work on it.
So is there a turbine for each unit?
Yes, sir.
Which unit is this? Is unit 2?
Unit 2.
I guess there has to be because we're producing on the other ones.
That's right.
And these are big turbines. Sometimes you'll see smaller ones, so there'll be more than one for each unit, but this is typical just to have a really big one with multiple stages. And when I say a big one, I mean a series on one shaft. So the high pressure and 3 low pressure.
Sorry for the dumb questions. I'm overwhelmed.
Not at all.
No, look, they're not dumb. I mean, I could tell that the Destin is an engineer, just not specific to nuclear power plants. Aren't any dumb questions.
So this is Unit 2's turbine. Are the other Unit 1 and Unit 2 turbines in a different room?
They are very similar to this, mirrored to this, just inaccessible right now because they're operating.
What's on the other end? Is the generator down there?
That's the generator.
Yep.
So you can kind of see, actually that's a good view. You can see some of your pole pieces in the generator right there.
How nice they're working on it.
Wow.
Oh, that's a good view. Yep, and you see the signs that say FME area up there as well, and that's because, well, the generator housing and components are disassembled. You really don't want to have any foreign material in there, especially the sort that conducts electricity. Yeah, everything's going to be de-energized now, but you don't want to run into problems when you start the thing back up.
That's amazing. Yeah, definitely. So in order to make a round thing run true, a lot of times you have an indicator that you put anchor it to something else and you touch off. And then as the thing rotates, you can see if it goes up or down. I see one of those, but it's where it is kind of confusing me. So that's a dial indicator. Philip, have you ever worked in the turbine area?
I have.
Have you ever worked on that?
Let me see what you're looking at.
Okay. Yeah.
I have not.
I have.
Fair question.
That's great.
Yeah, I suspect they're checking bearing.
I can't say I've ever done the mechanical or electrical work where you get in and tear apart the generator, that sort of thing. Again, my background's in engineering specific to the reactor, and operations, emergency planning, that sort of thing.
Yeah, it's checking for run out on the shaft.
Say it again.
Checking for run out on the shaft.
What does that mean?
If the shaft were not perfectly round, then as it rotated, you would see a change.
A form of degradation.
That distance that they're measuring.
How do they turn the shaft? It's massive, so how can they turn it into this motor?
This motor right here. It has a worm gear on it. That worm gear will drive that gear you can see there.
Oh, it's interfacing right there.
Right.
Is that the jacking motor you were talking about?
That's the jacking motor, yeah.
Oh, wow.
Could get a bit closer, but they don't want to get into the FMEA without having to essentially tie everything back off, just like they did. Though this zone might be an FMEA 2, so not the same level of restrictions, but good to stay out of zones like that unless you absolutely need to go in there.
So this motor is specifically to turn the shaft so that they can test it.
A lot of measuring and testing equipment is installed.
That is so cool.
This is 2 different sections of the turbine shaft. So they've got their dial indicator set up as a reference on one, and they're measuring the other. They're looking to see that those 2 shafts are lined up.
So they will spin one relative to the other.
Right.
So this is the exact junction between the turbine and the generator.
Yes.
Got it. Is there a clutch or anything there, or is it direct bolted connection?
It's directly coupled.
Really?
Yeah.
And so when it spins up,
I even had someone at the plant I worked with that was surprised that that was all on one shaft, but it's a fair question. But little things you go over in training.
you guys bring up a unit, will you get any wobble or vibration?
There'll be some, but it's minimal. It's contracted out. There's a crew that balances this thing, and it's amazing how close they balance it.
Really?
So, at least at the plant I worked at, you get an alert when the vibration gets up to 20 mils. That's 20 thousandths of an inch. And the turbine will trip when you get up to 40 mils. I mean, after all, 40 mils, even that little of vibration on something that size, you probably see the building start to shake a little bit. So that's why it trips at emergency, shuts down when you get to a point where the vibrations become excessive. Overall, not very much.
We spin this turbine, we keep very close eye on the vibrations on it. We're typically around 7 mils at worst.
Really?
Yeah. Well said.
On any bearing. There's 12 bearings that are through here. We'll watch every single one of them.
Really?
12 or 7 mils is about where we get it.
That's amazing for something this large.
Yeah. Oh yeah.
Yeah. Where is it machined? Where do you buy a turbine like this?
This is GE's turbine.
Oh, General Electric. Do they own the turbine too, or they made it?
They made it.
They made it and you guys bought it?
Yes.
Got it.
I live in North Alabama, so
Yeah, they don't typically. Yeah, it'd be weird to see someone like that own a portion of your plant's assets.
turbine. If I lived in the UK, we would say turbine. When it comes to making energy out of
I've seen this in the comment section before. Yes, what I'm used to and what everyone has said to me is turbine, whether they're referring to a steam turbine or a wind turbine.
steam, there's a lot of semantics that a lot of engineers like to get wrapped around the axle about, but
Or wrapped around the turbine shaft about.
we're not going to worry about that right now. I recognize that like energy and power and all these, they have specific engineering units, but for now let's just suspend all that and let's be kids talking about a really cool thing, okay?
Yeah.
So the cool
A roundy thing. Let's start with that.
about a nuclear plant is it makes steam. Like almost all power plants make steam.
Mm-hmm.
Steam is compressed and it's expanding if you allow it to, right? Well, we can use that. So I've got these little models here. These are little cheap little turbine blade things that I bought. And I've got one right here that's got a single turbine blade in it, right? And I've got this little valve set up right here to an air compressor. And
Simulate
if I turn
the
this
main
little
steam
valve
line.
right here, I can actually allow this thing to turn. Now this is a little different. This isn't expanding steam. It's just air running through this. So watch this. So I can create a gas that's moving into torque that turns a shaft, right? Now it's just compressed air. This is not expanding steam, but let's think about this for example. There's a lot of wasted air that's moving out of this thing, right? Well, what you can do for that is you can use multiple blades. So as the air comes in one side and it goes to the next one and the next one, if you have these multiple...
And keep in mind, at a power plant, it's not wasted. It's going to... The steam gets condensed and refed. I mean, you're operating in a cycle. There is a turbine that does exhaust to atmosphere. It was the Terry turbine because it's the manufacturer. It is a fourth string backup for the feed water system to provide it in the event you lose all electric power, basically the Fukushima type event. And there's also even more backups as well, but this one was installed when plants at around the time the plant I worked at was built. That one will exhaust to atmosphere. At that point, the name of the game is you just want it to work no matter what. You don't want to introduce any complications like having it operate in a cycle that can potentially prevent it from fulfilling its safety-related function.
blades stacked up, you can get more energy out of that gas. So I've got
Yes.
another valve here, so I can turn this thing.
Less air coming out.
Okay, get the idea. Multiple blades, I can get more energy out of the steam. So again,
And then you can extract steam from those and have that steam help preheat your feed water to make your cycle more efficient as well.
this is compressed gas, this isn't steam, but it's interesting.
Yeah.
Now, let's look back at those images from those turbine blades that we saw earlier. This is a turbine blade from when Browns Ferry was first being constructed. You notice it's got like this bow tie looking shape to it. And then this is a turbine blade from a recent upgrade of the Unit 2 steam turbine here at Browns Ferry. You notice it looks
all
like it's
shiny.
got
That's
little
cool.
things in the middle and then big things out to the side, right? In the middle, we have high pressure, and as it expands, it's like going to a lower pressure. You need
Goes
a
out both
larger
ends.
surface area on those turbine blades so you can act on it and get the same amount of torque, right? So that's why it's growing. If you look back at the actual turbine blades, you can see that the center
Also why there's
shaft is
multiple
solid,
stages.
and the reason for that is that's where the steam is inserted. It's inserted right here in the middle, and then it runs along the fan blades out each end of the turbine. And the reason it's a bow tie shape is actually fascinating. In my little model here, I've got a single turbine blade, right? You see that? So watch what happens when I apply the air. It's actually going to try to push it out. So watch this flywheel push to the side. You ready? See it? It's very subtle. And watch again. So it's actually trying to push out of the journal bearings here, so they mirror it, and that axial thrust is canceled out by the axial thrust in the other direction. So they flip the turbine blades on each side, which is fascinating. Now, Bill said there are 4 turbines in that building, 1, 2, 3, 4, and one seems to be smaller than the others. Let me show you how this works. So we have, in the reactor that we saw earlier, we have neutrons, right? Uranium-235, and these neutrons
again,
are in
I love
water
it.
in a very special way in the reactor core, but they're making steam, right? And they're making that steam at 1,000 something PSI, but it's coming off of that at like 900 something PSI after it goes through some valves
Yeah,
and
something
stuff.
less than 1,000, sure.
And so, 900.
It's flowing in
And
that
what happens
direction.
there is they take that steam and they put it in a high pressure steam turbine, right? So it goes into that bow tie thing, kind of like we were talking about earlier, but this is the high pressure steam turbine. Now, as it goes through that, it goes through the middle and it expands out. After that, you've got this other steam that's coming out of this thing. It's like 250 PSI, but it still wants to expand. So what they do is they take more steam turbines and they put them in the same
Gotta
room.
use as
Now
much
these
as
are
you can.
low pressure steam turbines, okay? So they take this 250 PSI steam and then they put it on all the different low pressure steam turbines like this. So you can take that and you can run them in parallel paths. So you've got this thing you've built now where you've got uranium making steam and you're pumping 900 psi steam into the high pressure turbine, and then out comes this 250 psi steam, and there's other things going on.
Interesting he mentions that. So that 900 psi number, the first stage impulse pressure is another way of measuring reactor power. There's a few different ways. One, you can just look at neutron flux and radiation detectors by just the amount of neutrons you're producing. Another is the heat, the number in megawatts that's being produced by the reactor, and also the number of megawatts going on the grid by the generator. And another is the impulse pressure that you are imparting to the first stage of the main turbine. I say the first stage because anything else will be affected by various losses of going through any of these lines he just drew. But the first stage is going to be the one that matters for determining what the reactor is doing. And then there's another one. It's known as the secondary calorimetric, which is basically a heat balance equation. And that one is typically going to be the most accurate. But you look at multiple versions of them just to see what you have going on. But yes, there's a lot of different ways to measure reactor power.
Separators and condensers that we're going to talk about right now, but these lower pressure steam turbines, they're bigger. And the reason they have to be bigger is because they're at a lower pressure. And if you're going to act on a lower pressure on a larger surface area, you can end up getting the same force because pressure is equal to force by area. You get it. You're smart.
It all comes back to force equals mass times acceleration. Pressure is the same thing, but in 3D.
What's going on here? So if we have all of these turbines on the same shaft, and then we put a generator there at the end, voila, we have a nuclear power plant. We've gone from hot rocks making steam, and that steam can go to making torque, and then we're putting all these different turbines on the same shaft. It's really cool, by the way, how they balance the torque along this. I think that's fascinating. Well, maybe we'll talk about that later. All that goes to a generator here, and you get electrons out the other side. So nuclear power to electrons.
Neutrons to electrons.
Fascinating. So
that one guy said.
Turbine, high pressure turbines, low pressure turbines, generator.
So high pressure side, low pressure, generator. Is that right, Bill?
That's right.
Okay. So, dumb question. Why is the high pressure upstream? So does the steam run down as it goes?
It's lower quality steam on the low pressure side.
But it doesn't run along the turbine. It runs in and out.
These are actually steam valves, CIVs down here, so it'll actually run in and out and under the generator.
Got it.
Or under the turbine, excuse me.
Generator.
This is an operating generator. So the generators...
Interesting, you can get relatively close to the generator, but not the turbine. I'm curious why it was set up that way at this plant, because you could get to the exterior housing of all of the things at the plant that I worked at.
From here to the wall over there.
It's just hard to hear you.
That's fine. The generators from here to the wall, and this is what's generating that 1,350 megawatts electric that you saw in Quinn's office earlier.
Yeah, so that meter in Quinn's office coming right off of this.
That's right.
That's cool. So it's quieter than I thought.
Yeah, it's not too bad. It's a little loud.
So what did we see in the other room? You said we couldn't go in that room normally.
The turbine. So that's the turbine that spins a rotor. It's got a common rotor.
So the turbine's that way.
That's right. So three things to make electricity, right?
Yeah.
Rotating element, magnetic field, current carrying conductor, right? So you got pole pieces inside this generator. You got a magnetic field on the rotor that's spinning, cutting lines of current down to the generator, down to the isolation buses, down to the grid.
So this thing right here is what makes 60 hertz power.
Yes, it is, absolutely.
So, like
60 hertz is grid frequency, and it's obviously you're producing power from the grid. It is important to match your grid frequency.
How do you synchronize this to the grid?
That's an excellent question. So typically what will end up happening is this is running at a certain speed, right? And I always like the phrase nuclear power equals 120 times the fun, right? That's an equation for us. NP equals 120 F. The speed of the machine times the number of the poles is equal to 120 times the frequency, right? So what we're able to do, what that really means, is frequency is directly related to the speed of the machine. So I can control the speed of this machine before we're synchronized to the grid to make it come up a little higher. If you think about your ice cream going for 3 days AC, right?
Yeah.
You can make it come up a little bit faster, and then we'll synchronize the grids. And we have this thing called a synchroscope. And it'll spin around, and when it's at 12 o'clock, it means the phase from the grid and the phase from the generator are synchronized, and we'll close it.
That happens right here.
Well, the breaker's down below us. They do it up in the control room.
Yeah, you do it in the control room, and the way I was taught is when you sync the generator, so the reactor operator has their hands on the main generator output breaker, they're watching the synchroscope, and you go slow in the fast direction, watching it go like a clock. He says at 12 o'clock you're matched, which is true, but like he said earlier, you pick up a little bit of the grid first. So while it rotates, you typically close it right when you see the synchroscope pass 1155, and then you immediately start raising power to make sure you're going the correct direction, and you don't reverse power the generator, which would kind of convert it into a big steam pump and could result in some damaging torque being applied to the generator shaft. So it's a very important operation. It's just as critical as starting up the reactor itself is syncing the main generator output breaker. That is something that is trained on in the simulator extensively and just in time. It's known as just-in-time training for when you send the operating crews who are going to be doing it once you come up from the outage to perform the operation of syncing the main generator to the grid.
What's outputting the energy into the grid?
As we headed to the exit, I was just struck by how much Bill knows and how complicated this plant is, and I asked him about that.
There's a lot of things to know here.
There are.
Is it intimidating for you?
I think I saw it once in the comments section. Somebody said all roads lead to a nuclear power plant. There's a lot of multidisciplinary things that you need to know. And so from the jobs that I've had more specific knowledge in the reactor itself and more general knowledge, the sort of things that you get during SRO training of everything else when it comes to components like turbines, steam generators, backup diesel engines, that sort of thing. I didn't have much knowledge about the other components when I was in college. It wasn't until I started working at the nuclear plant. And it wasn't really until after I got my SRO license that I was able to get that much knowledge about the inner workings of the plant. But a lot of it is breadth more so than depth. There are people at the plant that I work with that know way more about valves or diesel engines than I ever will, because that's some of their specialization. And it's really about all these teams working together that give you the wonderful product that is a nuclear power plant.
When I first got into nuclear power, it was very intimidating. I had to study really hard, but the more and more you work here, the more and more you understand what's important, the easier it gets. You know, everybody has their little piece they understand too, right? And that's about working as a team. Somebody knows something better than somebody else.
Yeah, he's kind of saying the same sort of stuff.
Even when you think you know everything, I promise you don't. Yeah. Nobody here knows everything.
That is why I say what I say at the beginning of every video. I don't claim to know everything nuclear.
The last thing we had to do was exit the radiologically controlled area, which meant we had to make sure we didn't have any radiation contamination on us, which I thought was going to be pretty easy. So we took apart the camera gear and handed it over to be checked, and we failed.
Oh, come on, be clean. 4,500.
Is that a lot?
No, it's too high. Here, let's put your other one in over there.
Put this one in?
It's kind of the center there.
You got to be careful about how many tools you put into each individual monitor. These are tool monitors that check everything you brought with you.
All right, hopefully we'll get at least one camera out.
So we went back and we cleaned everything, gave it a really good wiping down to have it rechecked, and we failed again.
Now,
it can be a pain, depending on what you
possibly
got and where you were.
Possible radon gas.
This was most likely that radon that's emitted naturally, and the fact that the testing machines are so sensitive, they're picking it up.
George and I are slowly...
Another example of nuclear overkill.
The camera's out. Bye, little camera.
Well.
Yeah, cook it. Almost. Yeah.
We ended up disassembling the cameras because things could make it out if they were smaller physically for some reason.
Separate tool monitors
so once we disassembled everything and made sure everything was cleared to go, we passed.
Yeah, we made it.
Now that we had officially left the RCA, logged out of our RWPs, and turned in our dosimeters, we started to make our way out of the secure area.
A big thank you to Bill, Angela keeping us safe, Philip, thank you Clarissa, thank you George. I can't point at George because there's stuff that way.
Thank you for visiting us.
Thank you very much.
This was very eye-opening that he was able to do something like this. Props to everyone, not with Destin's team and everyone who works at TVA that was able to do something like this. Thanks so much for watching, and thanks so much for the recommendation.